Hello guys, this video will go over how to do back to the basics, which is your homework assignment that is going to be due Thursday or Friday of this week, depending on which class you're in. So what we're going to do is we're going to go through the first problem together, and you'll have to bear with me. I've been sick with a cold the last couple days, so if my voice is a little kind of snuffly, then you'll know why. So let's read the first question together. Miss Jackson is buying scientific calculators for her math class. She told the principal that a classroom set of 30 calculators would cost $388.50. The principal wants to know the cost of purchasing calculators for the entire school. How much would it cost to buy 300 calculators? So in each of these problems, numbers 1 through 4, we're assuming that the situation is linear. And what does that mean? Well, that means that we're assuming that there's a constant rate of change. So what I'm going to do, and this is the advice I would offer you if you have difficulty starting these problems, is I would try to set up a table where you have your inputs in one column and you have your outputs in the other column. Now, because the price of the calculators, the total price, is dependent on the number of calculators purchased, I have this variable, the number of calculators, in one column and the price in the other. So let's suppose for a second that Miss Jackson purchases 0 calculators. Well, how much would she pay? Well, if she's not purchasing any, then she's not going to pay anything, right? So if she purchases 0, then the price would be 0. So that's just an easy data point that we can start off with. And what does the problem also tell us? Well, the problem tells us that if she purchases a class set of 30, then she pays $388.50. So I can add that to my table as well. It's like my second row. 30 is $388.50. Now, if I were to calculate the rate of change for this situation, what would I do? Well, in going from 0 to $388.50, what's the change? Well, we know that $388.50 minus 0 is just, well, $388.50. So I'm going to write 388.50. In other words, that's what the price is going up by. And then what's the change over here? Well, in going from 0 to 30, that's just a change of, well, 30. That makes it easy. So with this information, can we calculate the rate of change? ROC. Yes. Well, if you can remember from class last time, the rate of change is nothing more than the rise over the run. In other words, the change in the outputs over the change in the inputs. So that's just $388.50 divided by 30. And let me grab my handy dandy calculator. What is that? That is hold on just a second to pull up. That is 388.50 divided by 30, $12.95. So each calculator costs about $12.95. So if we were to write this into an equation, the other piece of information we need is something called the initial value. In other words, what is the output when the input is 0? Well, it's easy in this case, it's just 0. So I'm going to circle this top line. So we know our B value, in other words, our y-intercept, is nothing more than 0. Okay? So if all of our linear equations are always written in this form, ax plus b, where the a represents the rate of change and the b represents the initial value, we already have those two numbers calculated. So if we plug everything in, then our function is going to be y is equal to 12.95x plus 0. and anything plus 0 is just itself. So our function in this case is y is equal to 12.95x. So we just came up with an equation from the information provided. So can we use this information now to answer the question? Yes. The question was, the principal wants to know the cost of purchasing calculators for the entire school, and there's 300 in the entire school. So this x is, in other words, is going to be 300. So if you plug in 300 for x, you can calculate y. And I'll let you guys do that on your own. So that's number one, okay? Number two is where it gets a little more interesting, because now you have a hiker climbing steadily up a mountain. If he reaches an altitude of 3,000 feet by 3 p.m., what will his altitude be at 6 p.m.? Well, this one is interesting because on number two, we can create a table, but we only really have one data point, right? Because we know that at 3 p.m., that would be the input, the hiker is at 3,000 feet. But do we know at what time he started? Do we know at what time the hiker started in this one? And the answer is no, we don't. It's not given in the situation. So can we do anything with that? And the answer is no, because we have to have at least 2 data points in order to calculate a rate of change, and we don't. We only have 1. So that makes this question unsolvable. So you'll just have to write y on that one. As for the rest, I'll let you guys finish this on your own. Remember, there is a second side to this, so hopefully this gives you enough to get started. Thank you.